So now in the last video we took these J310s, and both of them we had the gate tied to the source. Gate down here goes to ground, and then source, the middle pin right there. So I removed that jumper. We're going to replace it with a resistance. So this is a multi-turn trim pot. You can either use it as a voltage divider or as a variable resistor, which we are going to use in this video. We'll come back to that. So in any case, to check the IDSS, again, as I said before, the source connects directly to ground. The gate is also directly to ground. If you want to set a current below that IDSS, so IDSS is basically maximum current, and you can set it lower there by adding some resistance between source and ground right there. And we can adjust how much current is going to flow through with that, as long as we have enough voltage for the load that we are powering and for setting the current there. It will set the current even as the voltage changes after that point. But we're going to use this variable resistor so we can adjust the resistance and set it in real time. So now, for those of you unfamiliar with trim pots, they got the 3 pins there, and there's a resistive element, and it's circular, but in any case, it can be thought of as working its way from the far end to far end there. There's a wiper right there that connects along that resistive element. You know, it slowly moves as you turn this many times. But in any case, you can have, you know, a certain amount of resistance between those 2 points and a certain amount of resistance between those 2 points. But the full resistance is across both of these pins. So I'm going to set the circle back up there. Hopefully that makes sense. So I have the multimeter here. I just clipped these jumpers to these alligator clips. I clipped to the probe, and they got jumpers that I clamped those alligator clips to, so we can measure the voltage. So this will be, or not the voltage, the resistance. This will be the full resistance. It says 102 on there. It's a 1000 ohm trim pot. There you can see 0.9. That's across the 2 elements, and I believe this will say about 400 right there, and that's between those 2 points, which means we'll have, you know, somewhere around 600 between the other 2 points. So as you lower the resistance on one side, it increases on the other, and as you increase on one side, it lowers on the other. So again, it's multi-turn, and so I'm going to have to turn this many times, even though we're not going to change the resistance a ton. So going clockwise, we increase the resistance right there. And again, it would be lowering the resistance on the other side, and we could use it as a voltage divider to change the voltage. But we're going to start off with, you know, about 500 volts. We don't have to be exact here. Since the J310 is facing to the left, we have the gate, the bottom pin there, directly to ground. The source, we're going to have a resistor going between source and ground. So we're going to use, again, the top 2 pins, that resistor that we just set to about 500. So I can lay it there. That'll put 500 ohms of resistance between those 2 pins. And I know it's blocked, but nothing's connected to the drain up there right now. It's on its own row. And what we can do, we can pull back. There's already 5 volts at the supply right there, and we can see approximately how much current we have flowing through. A multimeter would be more accurate. So I'm going to the drain, the top pin. So that current we're reading there, that's the current flowing through there. So it's being set by the resistor and the transistor right there. So the component's limiting the current. And if we increase the voltage, it should stay the same. So it looks like it went up because it got warmer. But there we go, 10 volt. You know, it's relatively the same, even though we, you know, massively increased the voltage. So let's, yeah, we're fine doing that. Let's lower the resistance. So we saw it went higher when we went clockwise, once I can get in the slot there. And so if I go lower the resistance, we'll see it get to 10 milliamps at some point. And I thought this would go quicker than what it is. There we go. So yeah, we must not need much resistance, because we're probably getting close to where there's hardly any resistance there. So yeah, we're looking for 10 milliamps, which is the same as 0.01 amps. And so now, as a current source, we will move this jumper up one spot right there. It's on its own row. Let's move it over a little bit there. And I'm going to put an LED where that jumper is, the anode, and then the cathode where the drain is right there. And there you can see we're still 10 milliamps of current there. So we're setting the current through the LED, and I'm not sure how high voltage we can get. But again, let's go to 15. So it looks like it changed slightly, but there you can see it's holding really steadily, even though we tripled the supply voltage. Current held really steady. Of course, the multimeter would be more accurate. Let's get a look at with the current with the multimeter. So we're going to go to milliamps, because again, we are in milliamps, and we pretty much did this in last video, but we didn't set the current. So I'm bypassing the LED right now. We're just looking at the transistor, and so that's going to be more accurate than the power supply right there. Now we can come up to the anode of the LED, and there you can see. So looks like it changed, slightly right there, but it's really close to the same amount of current that we set there. And so there you go. It's slightly different with the LED for some reason. The LED does drop some voltage, so that reduces some strain on the transistor there. So maybe that's why. And another thing we can do, I turned the multimeter off on the last scene. You don't want to leave it measuring current. That's an easy way to blow a fuse if you accidentally try to measure voltage or something while it's set to measure current. But there's a backlight there if I cover this. I put the jumpers next to each other there to save some time right there. We can look at what the resistance was that we needed to, looks like we got about 11.5 milliamps of current flowing through there, approximately 10. And if we have a solid connection, it'll steady. But yeah, it looks like we need about 120 ohms of resistance. So if we don't want to add, a trim pot, we just want to get that, close to 11 milliamps of current going through there, even as we change the supply voltage. We now know we can just grab 120 ohms. Probably won't find a single resistor that's 120 ohms, but there's ways that you could use a couple of resistors to get that much resistance. And you could set the current that way, and we just know with this particular one we'll get that amount of current. This one will probably be slightly different, but you can set or figure out how much resistance you're going to need with the trim pot there very quickly to get the current you want, and then grab fixed resistors afterwards. Hopefully that makes sense. Make sure you turn off the meter when you're done. So in any case, I hope you enjoyed this video. I went on longer, but I did a number of demonstrations, so hopefully you still enjoyed. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.